Alright guys, so the next skill we're going to learn about, and it's going to take a couple of lessons, is all about factoring polynomials. Now, we've done factoring before in our earlier math classes. For instance, maybe we used to factor the number 28. And to factor 28 means find two numbers that multiply together to give 28. So maybe you said 28 was 2 times 14. Or maybe you said that 28 was 4 times 7. But that was the general idea. And now we're going to do that exact same skill, factoring, but just with polynomials. What we've done already is learn all about multiplying polynomials. So for instance, we've done things like multiply 2a squared times the quantity of 3a plus 5. And when we do that, we got 6a to the third power plus 10a squared. And now the skill we're going to be working on is taking this polynomial right here and determining what two polynomials multiply to give it. So we're going to go from this polynomial and say, you know what? This is equal to 2a to the second times 3a plus 5. Or for instance, we used to multiply something like negative 3b times the quantity of 2b squared minus 4. And in this case, we got negative 6b to the third power plus 12b. And again, our new skill is going to be all about taking this polynomial and figuring out what two polynomials multiply to give that, namely negative 3b times 2b squared minus 4. Now, there are a lot of skills we're going to need to learn, and we're going to take them one step at a time. And our first skill is to learn how to take the individual terms of a polynomial, find their greatest common factor, and use that to help us factor the entire polynomial. So let's start with an example. For instance, what about the binomial 6m to the fourth power plus 21m to the third power? So what we want to do is we've got two terms here. We've got 6m to the fourth and we've got 21m to the third. And what we want to do is we want to find the greatest common factor of those two terms. Now I'll tell you, the first place to look is just at the coefficients. So we've got a coefficient of 6 and we've got a coefficient of 21. And their greatest common factor, I hope we can agree on, is 3. So I'll tell you now that the greatest common factor for these two monomials, its coefficient will be 3. Okay, now let's look at the variable parts. We've got a m to the fourth power and an m to the third power. And what I'll tell you is that the greatest common factor of m to the fourth and m to the third is actually m to the third. Now, that may be confusing right now, but give me just a moment, and I think what we do next will really clear things up. So I claim that the greatest common factor of these two individual terms is 3m to the third. That means we can multiply 3m to the third by something and get 6m to the fourth. Maybe you can figure that out in your head. We can also multiply 3m to the third by something and get 21m to the third. So what that means is that we can rewrite this polynomial right here, and we can rewrite it as 3m to the third power times something. So what do we have to multiply 3m to the third by to get 6m to the fourth? I think we're going to need to multiply by 2m. What do we need to multiply 3m to the third by to get 21m to the third? We got to multiply by 7. And so what we've done is we've taken this original polynomial and we used its greatest common factor to what we call factor it out. And this is the factorization of this polynomial, because if you were to multiply 3m to the third by 2m, we get 6m to the fourth. If we multiply 3m to the third by 7, we get 21m to the third. All right, let's do another example. So for instance, what about 8g squared plus 12g to the fifth? All right, so we want to find their greatest common factor. Again, the first thing we want to do is look at those coefficients. So 8 and 12, their greatest common factor is 4. So the coefficient of our greatest common factor will be 4. Now let's look at the variable parts. We've got a g to the second power and a g to the fifth power. Once again, maybe this part's a little confusing, But I think that the greatest common factor of g squared and g to the fifth is actually just g squared. And if that doesn't make sense yet, perhaps what we do in the next few moments will help clarify. So I think our greatest common factor for these two will be 4g squared, meaning we can multiply 4g squared by something and get 8g squared, and we can multiply 4g squared by something and get 12g to the fifth. So this means we can write this big polynomial as 4g squared times something. What is that something? Well, we need to multiply 4g squared times 2 in order to get 8g squared. So 2, and then we need to multiply 4g squared by 3g to the third in order to get 12g to the fifth. So 3g to the third. And we've successfully factored this polynomial. Now, I do want to make a note, which is that in general, the first thing we wish we had done is take the original polynomial and put it into standard form. That's just a best practice, and we're really going to want to make sure to do that every time. It wasn't extremely important this time, but it will be really important in the future. So we would have written this as 4g squared times 3g to the third plus 2. And that means that what we're left with in the parentheses also ends up being in standard form, which is really great. All right, let's proceed. What about another example? So how about 3x to the third minus 5x squared? All right, this one is already in standard form, so we're ready to go ahead and try to factor. Well, I'm looking at the coefficients 3 and 5, and their greatest common factor is 1. They don't have any factors in common. So let's look just to the variable terms. X to the third power and x to the second power, their greatest common factor is x to the second. So that means we can rewrite this polynomial as x squared times something, and we'll get this original polynomial. So I think x squared times 3x will give 3x to the third, and I think x squared times negative 5 will give negative 5x squared. And in general, my strategy for finding this greatest common factor, and it's the same strategy I used for this one and for this one, is start by looking at the coefficients of your terms in question and find their greatest common factor. So the greatest common factor of 6 and 21 was 3. The greatest common factor of 8 and 12 was 4. The greatest common factor of 3 and 5 was 1. And after that, we look to the variables. And to find the greatest common factor for those variables, just look at which term has the variable raised to the smallest power. And that will be your variable part of the greatest common factor. So m to the third was the smallest power, smaller than m to the fourth, so m to the third was in our greatest common factor. G squared was the smallest of all the powers of our g's, so g squared was part of our greatest common factor. X squared was the smallest exponent on our x's, x squared was our entire greatest common factor in this case. I want to do one more. Okay, so how about negative 28 h to the third power minus 8h to the fourth power? First things first, let's go ahead and put this right into standard form because we know that's a good idea. So negative 8h to the fourth minus 28h to the third. Now, both of these terms have negative coefficients, but for right now, let's just forget about those negative signs for now. And let's concentrate on the greatest common factor of 8 and 28. I think their greatest common factor is going to be 4. So 4 is going to be part of our greatest common factor. I'm looking at the variables. I see an h to the fourth and an h to the third. So h to the third will also be part of our greatest common factor because we're just looking for the exponent that is the smallest on our variable parts. All right, so what do we need to multiply 4h to the third by in order to get our original polynomial? Well, I think 4h to the third times negative 2h will give negative 8h to the fourth power. So negative 2h. And I think 4h to the third times negative 7 will give negative 28h to the third power. So minus 7. And we have successfully taken our original polynomial and we have factored out its greatest common factor. Now, one thing I want to say is when we are factoring out a common factor, we really tend to want it to be the case that whatever's left in our parentheses, we actually want that leading coefficient to be positive. It's really just a best practice. It'll make our lives a lot easier in the future. So instead of having a negative 2h right here, we would really prefer to have a positive 2h. So how can we do that? We can factor out an additional -1 from both this negative 2h and this negative 7. So what this would actually look like when we're all done is negative 4h to the third times the quantity of 2h plus 7. So just something to keep in mind. And if it's ever the case that you factor something out and your leading coefficient is negative, all you need to do is change the sign of this common factor out in front from positive to negative, and boom, this coefficient will change to positive, just like we like it to be. All right, just a few more examples left in this lesson. Let's highlight all of these that we've already done, and let's shrink them all down and put them in the corner. So we've got them there in case we want to reference them, but there's some more I want to do, so I wanted to make some space for them. So what happens when our polynomial now has 3 terms? So for instance, what about 30 plus 45b squared minus 25b to the 4th? Okay, so first things first, let's go ahead and put this in the standard form. Always a good idea. So negative 25b to the 4th power plus 45b squared plus 30. All right, and the strategy is going to remain exactly the same. We're going to want to find the greatest common factor now of all 3 of these terms. Well, let's start by looking at the coefficients. I see a coefficient of 25, I see a coefficient of 45, and I see a coefficient of 30. And I think the greatest common factor of 30, 45, and 25 is 5. All right, now what about the variables? Well, these first 2 terms have b's in them, but this last term does not. And so we might think, oh, maybe the greatest common factor will have a b squared in it, but alas, if we want to try to find a greatest common factor for all 3 of these terms, well, it's got to be common to all 3 of them. So if we were just dealing with these 2, absolutely, we would put a b squared right here. But since we're dealing with all 3 of these terms, 5 is it. That's all we got. There is no other part of this common factor. This is all we're going to be able to factor out is a 5. So that's really important, that if you're trying to factor out a common factor, it has to be there for all of the terms in your polynomial. So we're going to write this as 5 times something. Well, I think it's going to be 5 times negative 5b to the 4th plus 9b squared plus 6. All right, but I do notice that we have a negative 5b to the 4th as our leading term in our remaining polynomial, and we know we like to have a positive leading coefficient in there. So instead of factoring out a 5, let's factor out a negative 5 here. So we'll rewrite this as negative 5. We're just going to change the sign of this term out in front, and then we'll end up with positive 5b to the 4th minus 9b squared minus 6. And we strongly prefer this version because we really like to have a positive leading coefficient right there. Okay, just 2 more. Here we go. How about 4w to the 3rd plus 5w squared minus 13. All right, let's look at the coefficients. Let's see if we can find a common factor. So I see a 4, 5, and a 13. I can't find any common factors for those. So far, we're coming up dry. What about the variables? Well, the first term has a variable, the second term has a variable, and the third term does not, though. So, in fact, this polynomial right here doesn't have any common factors that we can factor out. It doesn't mean that we can't factor it somehow later using a different skill, but at least this skill of finding a common factor is not going to be fruitful for us. So right now, all we do is just kind of leave this as is. There's nothing we can do to it. Okay, last example before we finish up. How about this? Negative x squared plus 6x minus 9. All right, so when I look at this polynomial, I'm looking at the coefficients. Negative 1, 6, negative 9. Or you can even just think 1, 6, and 9 for now. No greatest common factor there other than just 1. And I see a variable here and a variable here, but no variable there. So at first glance, we might say, there's no common factor, there's nothing we can do. And you would be right. But there is something we can do that will make our lives easier in the future. I'm noticing that the leading coefficient of this polynomial is -1, or it's negative at all, and we don't like to have a negative leading coefficient. So what I want to do is I want to factor out a -1 from this big polynomial. And I want to write this as -1 times something. Well, this shouldn't be too bad. All we're going to have to do is switch the sign of each of these coefficients. So we have -1 times x squared minus 6x plus 9. And of course, this -1 right here, you can just write that as negative x squared minus 6x plus 9. And why is that helpful? Doing so in the future might allow us to recognize that, oh, we've got a special polynomial in here. We can factor this some more using a skill that we'll learn soon. So that's it for this video. I hope you found it helpful, and I hope you enjoyed.